Today we are going to take a look at some more information about exponents. We started very briefly last time, did just a couple of things, sort of just defined the way exponent notation looked. But today we're actually going to take a look at quite a few properties of exponents. And I'm also going to show you why the properties work. Not because I'm going to ask you, why does it work? But because sometimes I feel like math looks a little bit like magic or, like hocus pocus, like somebody just created something and we just use it. And that's really not the true reality for exponents. There's actually very good reasoning behind each of the rules that we have. So I have 7 different properties we're going to take a look at. The first one tells you what happens when you have a to the m times a to the n. Does anybody remember what happens when you simplify that? Yep, you add the exponents together. Okay, that is what happens. And to sort of justify it, this isn't exactly a proof, but it's a justification by example, which is oftentimes enough to see why something's working. We're going to take a look at what happens when we have a cubed, a squared. So a cubed means we have 3 a's, right? A times a times a. And a squared means we have 2 more a's. And if you count these, how many a's do you now have? 5. So this is simply a to the 5th. And if you take a look again back at the exponents, how do you take 3 and 2 and get 5? You add them. Okay? So that's sort of the justification for why that property is addition as opposed to, say, multiplication. The second property, what if we have multiplication and it turns into adding exponents, what do you suppose division is going to look like? Subtracting, right? So it's m minus n. And again, a y. We're going to do a to the 4th over a to the 1st. And as you know, a to the 4th means you have 4 a's. A to the 1st is 1a. And then what do you know you can do when you have a whole bunch of multiplication on top with the a on the bottom? Yeah, you reduce them, right? That's a fraction reducing like we've been doing in sections 1.3 and 1.4. And so I'm left with 3 a's on top. And again, how do you get from 4 and 1 to 3? You subtract, right? Now, 3 kind of looks like 1. How is 3 different than 1, the way it shows up? There's a couple things you might notice being different. That's actually the most important thing. I'm glad you mentioned that, Reed. Yeah. So on number 1, we have a listed twice, and each of them have exponents. But on number 3, a is not listed twice, right? What's the other thing that you notice? The parentheses, exactly. The parentheses, which means that we are actually taking everything inside of there, and then now that is being raised to the power n. So when we have a power raised to the power, we don't have the 2 bases being listed side by side. What we actually do is we actually multiply the exponents. And I'm going to show you why that works by doing a cubed squared. All right, so a cubed means a times a times a. And then squaring that means doing that a times a times a twice. And how many a's did that end up leaving you with? There are 6 of them, so this is a to the 6th as opposed to a to the 5th, which is what we had before. And how do you get from 3 and 2 to 6? You have to multiply, right? All right, number 4 and 5 are very similar. They feel like it's sort of a distributive property to them. We have multiplication a and b, and it's raised to a power m. And when I do that, I can distribute that m to the a and the b. It's really important that the a and the b are multiplied. If the a and the b were added, this wouldn't work. It would not be true. So again, let me show you why it works, and we'll do this with a power of 3. So a power of 3, of course, means that we multiply something by itself 3 times, right? And then one of the properties that we encountered back in, I don't remember if it was section 6 or section 5, one of the properties that we encountered said that we have the ability, when everything's multiplied, to sort of change the order of multiplication, right? So instead of being AB times AB times AB, I can reorganize it and put all the A's together and put all the B's together. That is acceptable. And if I do that, you see that there are 3 A's, there are 3 B's, so this is actually A cubed, B cubed. Okay, we don't have the ability to shift it all around like that if part of it's being multiplied and part of it's being added. But this is all multiplication. I actually think that the 5th rule looks even cleaner with this idea. We can sort of distribute, again, that power of m through. And we'll use that power of 3 again as my example. So we have a over b cubed. So this means a over b times a over b times a over b. And if you kind of multiply across the top and multiply across the bottom, right, there's a, b, and this is a cubed over b cubed. So we don't even have to sort of reorganize it like we did with multiplication. Okay, so are those 5 okay? Those are the most basic properties that we see used frequently. The next 2 are less common but still very important. But any questions on those first? Awesome. All right, does anybody remember what happens when you raise something to the power 0? You get a 1. That's right. Avery's telling me back there you get a 1. So I'm going to actually prove to you why this one works. Like, this is a legit proof, not just I'm going to justify it with a simple example kind of thing. This is actually a proof. So we're going to take the a to the 0 and we're going to write it in what seems sort of a funny way. We're going to write it as m minus m. So hopefully you're looking at it and you're like, well, yeah, but why? Are you? It's true. It's true. So we can do that. So why am I doing that? Well, because what I want to do is I want to use the property number 2 in reverse. That is to say, I want to rewrite this as a to the m over a to the m. And that's property number 2 over here, sort of used backwards, right? This says a to the m minus m, so I can rewrite it as a to the m on top and a to the m on bottom. But what happens when you divide something by itself? It becomes 1. So no matter what exponent I would have chosen, that's why I chose an arbitrary m, this property holds. Why don't you put the phone down? Join us, Cole. Thank you. All right, last property. The last property tells us what to do with negative exponents. Now, this negative exponent is understood to sort of be in the numerator because there isn't a denominator, or you can think about it as being over the number 1. But negative exponents actually change locations between numerators and denominators, or you can think of them as becoming reciprocals, those kinds of languages. And so this actually, becomes 1 over a to the n. Okay, it flips the location. And I'm going to prove this one as well. Again, an actual proof. So a to the negative n is actually the same thing as a to the 0 minus n. That's what negative n means, right? It does. And so this looks a lot like that last proof. I'm going to put the a to the 0 on top now and the a to the n on bottom. And what's a to the 0? 1. I just established that in the previous property. So now I have 1 over a to the n. So if you want to like completely forget everything about why they work, that's fine. You can do that. What's valuable and important is remembering what the properties actually are for the purpose of doing your homework. Okay? So we're going to do a lot of examples to give us some really good practice before we get to our homework at using these properties. I'm not asking you to justify, like in your homework, which property you're using, but I may ask you in class right now, why are you allowed to do that? Okay, so what property are you using? So we're going to take a look at the very first example. This is x squared, x to the fifth, x to the fourth. What will I do to simplify this into a different form? Add the exponents, and that's the first property, right? The very first one we did. It only set it for 2 exponents, right? 2 bases with exponents, but it works for however many we have. So what is 2 plus 5 plus 4? It's 11. Okay, so some of them don't require very much work. Some will require more. This is simply x to the 11th. Our next one, you'll notice there's pieces that are numbers, like coefficients, and there's pieces that are variables. So if it helps you to think about rewriting them, you may, or you can sort of just think about it without rewriting it too. We're going to multiply all the coefficients parts together, and then we're going to multiply all the y parts together. So this is actually, I'm going to put it even as y to the 1 at the end to remind ourselves it has an exponent of 1. Okay, so if you don't want to write that step, that's fine. You don't have to. But that is what we're doing. We're reorganizing the list of numbers and numbers and variables. So what is negative 4 times negative 3 times negative 2? Right, it is negative, and it's 24. And then the y squared, oops, that's a typo, y cubed, and then y to the first that I took from the problem. Look a lot like problem number 1 we just did. What will I do with those exponents? I'll add them, and I will get y to what power? The 6th. Okay, we're good? All right, cool. Let's do another one. Now, this one has the caveat, if you will, that there's some x's and there's some y's. So again, if you want to reorganize them and put all the numbers together, 6 times 4 times 2 times 3. Put all the variables together, so it doesn't really matter what order you do. I usually go alphabetical personally. It's x cubed and x, and then y squared and y cubed. If you don't go alphabetical, it's fine, it doesn't matter. So we'll multiply all the numbers together. What is 6 times 4 times 2 times 3? 144. Yes, indeed. Now I have x cubed and x to the 1, which means I have x to the 4th, more of property number 1. Then I have y squared and y cubed, which is y to the 5th. Perfect. Nope. If you want to write y to the 5th and then x to the 4th, that's cool. No problem at all. All right, so all of those were actually just property number 1 applications. All right, we applied property number 1. What property are we taking a look at on number 4? Yeah, property number 3. So what happens when we have x squared to the 4th? What do we do with those exponents? We're going to multiply them this time. So what is x squared to the 4th?
X to the 8th.
Right, x to the 8th. Okay? And yes, some of your problems will be just like that. One step, quick and dirty. You can do it in about 5 seconds kind of thing. Okay, number 5. What property is number 5? It's not property 3. It's actually property number 4. It looks like this one, except that one of them is a number and one of them is a variable instead. But it works the same way. We're going to distribute the power 3 to the number and to the variable. So this is 4 cubed and u cubed. So the most common tendency is to forget to do it to the number, that the coefficient doesn't get the exponent distributed to it, but it does. Okay, so what is 4 cubed? 64. and then we have u cubed. So please remember to distribute the exponents to coefficients just like we do to variables. All right, number 6. Now number 6 is actually two properties combined. You knew it was going to happen eventually, right? All right, so it's property number 4, like it just had, because I have multiple things inside with a power on the outside, right? But I also have an item inside, the y squared, that is now squared, and it's actually then raised to the power of 3. So that's actually property number 3. So we're going to distribute the power to each of the pieces. So if it helps you to think about it, you can write it out, 3 cubed, x cubed, and then it's y squared cubed. That's really what we're doing. Again, that's one of those steps that you may or may not actually want or need to write down for your own benefit. What is 3 cubed? Somebody said 27, you're right. That's a terrible 2. Let's try that again. X cubed is x cubed, no problem. But what is y squared cubed? That's y to the 6. So that's property number 3. Okay, so far so good? Because once I flip the screen, we're changing into something that's considerably more difficult. So it's more difficult because there's more going on. But in part, there's more going on because I have denominators. So if it helps you, let me just kind of throw some things out there. You could write this out as negative 2 over ab squared times negative 2 over ab squared times negative 2 over ab squared. You can do that. You don't have to. You can also just think about it as distributing the power 3 through every piece. But it also has to be distributed through the negative portion of this. So when I multiply this out, I'm going to have 3 negatives. So if I multiply negative times negative times negative, what do I get? It's negative. So you have to think through that. On this one, it's going to be negative. If I did it 4 times, I would actually end up getting a positive. So be aware of it happening. I will have to distribute it to the power 2, or to the number 2, to the a, and to the b squared. So we already said that I have 3 negatives. That's a negative. I have 2 cubed. And then I have a cubed. And again, you don't necessarily have to write it this way, but if you want to keep track, or if it's helpful to you to keep track of it this way, it's b squared cubed. So, what is 2 cubed? 8. I have a cubed, and then I have b squared cubed. B to the 6th, right? Okay, is that good? We're tacking on more pieces as we go. So if you have a question, please stop me, because they're only going to get messier for the most part as we continue. Okay, 8's actually not too bad because 8 doesn't have any exponents to distribute, but it does look a lot like one of the different values that we've had before earlier on in an earlier section. So we're actually going to be comparing top to bottom, the 14 and the 35, the x and the x, and then I just have y all alone by itself. So when I'm looking at 14 and 35, what do they both reduce by? 7. They both divide by 7, right?
Yes.
So what is 14 divided by 7? 2. And what is 35 divided by 7? 5. Fabulous. All right, so aside from the division by 7, what else do you notice is possible on this one? Yeah, the x is reduced, right? X divided by x is 1. They cancel. Whatever language it is that you feel most comfortable with, they're going to divide to 1. They're going away. The y, however, doesn't have anything to pair with it to change anything of its value, so it simply stays there. 2 over 5y. So I'd like to combine sort of that idea with some of our properties in number 9. There's 2 different ways you could There's probably more than that, but there's at least 2 different ways you could think about this, okay? So let me show you one way. Don't write anything down, and then I'll show you a second way, and you can decide which of the 2 you like the best, and you can record that one, okay? So one option for this looks a lot like number 8. What it does is you're sort of thinking about the fact that x squared is x times x, and y to the 6 is 6y's. And this is over an x, and it's 2y's, and then you're reducing by canceling like terms. I get rid of one of the x's, I get rid of the 2 of the y's, I'm left with an x, I'm left with 4y's, and this is x, y to the 4th. Totally reasonable way to do the problem if you choose to do that. So that's sort of option number 1. Let me show you what option number 2 would look like. Option number 2 would look like using the properties of exponents, namely the one about subtraction, property number 2. Property number 2 says that I can take the numerator's exponent minus the denominator's exponent. Whoops. So I can write this as x to the 2 minus 1 and y to the 6 minus 2. It's the exponents from the top, the exponent from the bottom. 2 minus 1 is 1, 6 minus 2 is 4, and it's y to the 4th. There's less writing, but it's a little more hidden what's going on. Yes, Anya? You got to show me something. Yeah. Because once we get to here, you're actually doing properties where you're showing pieces. So to give you an example, I have another class right now who's working on something for me where they submit it multiple times. And they have one right now that looks like this. I think this is what it looks like. That's where they get down. When they get to a certain point in the problem, they get to this. And I cannot tell you how many times there's mistakes made at this point because they do different things. But if they show me their work, I know what the mistake is they're making. And if they give me an answer, I don't always know what mistake they're making. Because there's several ways to approach the problem here at this point. Most of the time, they're telling me that this is a to the 10 minus 15, which gives me a to the negative 5. This is false. Don't write this down, which is this. And it is not. But if they show me some of those steps along the way, I know the mistake they're making, and I have a much better way to help them understand the mistake instead of just getting from here to here and me going, what'd they do? So that's the actual reason why. Okay, it's a completely different class. It's not even an intermediate algebra class. So there's a couple of ways to do number 9. Any questions on either of those methods, or if you've tried to do something different maybe even? There's one other option, but it's super less common, so I don't usually talk about it. So, okay. We can do the same thing on number 10. We can actually write them all out and cancel, or we can reduce them using subtraction. So I'm going to show both options again one more time, just so that you can see them at play. So option number 1, which honestly, option number 1 will work just fine. If the numbers get too big, you probably don't want that, right? Like if you had a to the 100 over a to the 94, probably not option number 1, just saying. But when the numbers are small, and most of the time the ones you have will be, we can do option number 1. So this is U, W, W. Then I have 4 U's, and I have 6 W's. Okay, so if I do this option, I cancel one of my U's. I cancel 2 W's. 3 U's are left, and 4 W's are left, and they're in the denominator. So it's U to the 4th, U to the 2nd. It's 2 left, 3 left. U cubed, W to the 4th. That's the one that's got 4 left. And it's 1 on top. When you reduce things, when they divide out to the number 1. So this would be option number 1. Option number 2 isn't quite as neat as it was in the last problem, but it's still possible again. The U on top has an exponent of 1. The U on bottom has an exponent of 4. So this is 1 minus 4. The W on top has an exponent of 2. The W on bottom has an exponent of 6. So it's 2 minus 6. All right, so what is 1 minus 4? Negative 3. And what is 2 minus 6? Negative 4. And you do not get to leave your answer with negative exponents, so they will go down into the denominator. So if I put them into the denominator, that eliminates the negative, because that's what the is doing. That's what's happening when we do reciprocals, and I end up in the same place. I do have that one additional step at the end that I didn't have on the previous problem, because the exponents ended up being negative this time. All right, so I will stop showing you option 1, option 2s if we have any more of them. I tend to go with option 2 because there's less writing. So that's the one that I will probably tend toward, but you can use option 1 if you prefer. All right, what do you notice on number 11 that we haven't had in any of our examples so far? The examples specifically. Power of 0. Okay, so the power of 0 means that everything that's raised to it, which in this case is the 4w, is all going to become 1. Don't make the negative 3 become 1 because it doesn't have an exponent of 0. So the negative 3 is still there. The 4w to the 0 is 1, which leaves you with negative 3. Okay? Again, the tendency is to see the 0 power and you just to tell me that it's the number 1. Make sure that you're actually getting the right piece that's becoming 1 and not necessarily the whole thing. Okay, number 12. We haven't seen one like number 12 before. The thing that makes number 12 interesting is that while it's a negative exponent, it's also a negative exponent on a fraction. And we haven't even talked about that at all. So when we have a fraction and we have a negative exponent, well, actually, let me go backwards. When we had a whole number and we had a negative exponent, it just moved it into the denominator, right? The reason that happened is because the reciprocal happened. So when we're dealing with something that's actually already in fractional form, the reciprocal doesn't just put everything in the denominator, it flips numerators and denominators. So I'm going to deal with just the negative part first. If you want to deal with more than just the negative part at one time later, that's fine. But I'm just going to deal with the negative. And it's going to flip my fraction. So I have a 3 on top and a 2u on bottom. And now instead of having a power of negative 2, it's a power of positive 2. The negative gave me the reciprocal. Okay? And now I'm back to distributing the power. So I have 3 squared, 2 squared, and u squared. Again, you don't have to show this all out, but show me something along the way. This is 3 squared, 2 squared, u squared. What is 3 squared? 9. 2 squared? 4. And then u squared. So I have 9 over 4u squared. Wow, number 13 seems easy after all that. X to the negative third times x to the negative sixth. What do you do with those exponents? You add them. So negative 3 plus negative 6. What is negative 3 plus negative 6? Negative 9. And then it's 1 over x to the 9th. You got it. Okay, one more that's kind of like 13. Y to the negative 1, y to the negative 5, y to the 4. What am I going to do with those exponents? I'm going to add them. So negative 1 minus 5 and plus 4. It's not really minus 5. I should write it better. But it's plus a negative 5 and plus a 4. So what is negative 1 plus negative 5 plus 4? It's negative 2. So this becomes y to the negative 2. Right? It's 1 over y to the power 2, or squared. Fabulous. So again, you're showing me something along the way. I maybe should make mention that this isn't the only way to do this problem, but it sort of feels natural because they're all listed this way. But if you have a different method that you're used to using and you just want to just double check with me as you're doing work here in class today, just do that, and we'll see if it would work in general. All right, 15. Our last one before we get a chance to do some problems on your homework. This one's kind of messy. You got lots of things you could do first, so I'm going to let you guys tell me, what do you want to do first? You want to distribute the negative 3? Okay, So if we distribute negative 3, we need to be careful that the negative goes with it. So it'll apply here, and here, and here, and here, right? 4 pieces. So now I have, x to the negative 3, y to the negative 6, over, it's not negative 3, x to the positive 6, because the x down here in the bottom has a negative exponent already, so negative 2 times negative 3 would be positive 6. And then y to the negative 3. There's so much marker and pen now going on here, you can't tell. Okay, so tell me that again, Malik. You could. Okay, so anything that has, this is another thing that we haven't talked about, but it definitely works. If you want, you can subtract exponents, right? You can do x to the negative 3 minus negative 6, or minus 6, y to the negative 6 minus negative 3, or you can do what you suggested, Malik. So tell me again what it is. Close. Okay, so anything that has negative exponents, what you're saying is you want to move them. Does that sound right? Okay, so the one caveat that we need to be careful of is that if the power is already positive, it doesn't move. So the x to the 6th is already positive, it's not going to move. But everything else has a negative exponent, so it can move. So x to the 3rd would move to the denominator. Y to the 6th would move to the denominator. And y to the 3rd would move to the numerator. Again, that's another way of dealing with this problem. It's not finished yet, right? But we could do that. We could, definitely could do that. The x's are actually in the same spot, in terms of numerator, denominator now, so that's kind of nice. So I have x to the what in the denominator? The 9th. In the numerator I have 3y's, and in the denominator I have 6y's. How could I reduce those? What's that? Okay, if I were adding them, it would become y to the 9th, but they're not in the same place. One's on top and one's on bottom. So you could subtract them, or you could eliminate them. So since they are where they are, I'm going to eliminate. There's 6y's on bottom, and there's 3y's on top. So 3y's cancel in each location. And what do I end up having? Y to the 3rd in the denominator. So right now I don't have anything written in my numerator. What should be written in my numerator? A 1. Okay, I want to go back and do the problem a different way too. Because what I just did there was completely not how I've been showing you. It is all correct though. It all works. So let's go back and try the problem with a little bit different approach. There's lots of options. I'm not even going to call them option 1 and option 2 because there's probably 15 options here. But we'll just do it in a different option. So I mentioned before that negatives could flip things, right? So if you wanted, you could flip everything. So we would end up with the x to the negative 2y on top and the xy squared on bottom, and then the power is a 3. Okay? That's kind of nice. That should be a negative 2, sorry. That's kind of nice because I don't have as many negatives. Negatives somehow feel a little bit less friendly in the problem. So this is one option to sort of handle that. You can distribute from there if you'd like. So that would give me x to the negative 6th. You'd have y to the 3rd over x to the 3rd, y to the 6th. Obviously it looks familiar. It's what we ended up with later on in the other problem, right? If you want, you could move the x to the negative 6 in the denominator and it would look just like what we did before. Or if you want, you can subtract exponents, which is what some of you were commenting on when Malik and I went down a different road, right? It's x to the negative 6 minus 3. Let me shift this down a little bit so more space. And then I have y to the 3 minus 6. So what is negative 6 minus 3? Negative 9. I'm sorry, that's supposed to say x. X to the negative 9. And then 3 minus 6 is x to the negative 3. I'm sorry, still y. Y to the negative 3. So you still see that 9 and that 3, right? And they're both negative, which means that we put them both back into the denominator. And I keep switching my x's and my y's. How about that? And a 1 on top. Okay, all of my order was all mixed up and changed, but I still end up the same answer because all of the moves are still valid moves. All right, that's it for homework, or for section 1.8. So I'd like for you to go ahead and get out your homework 8, and let's start taking a look at working through those in class. You have, it looks like 17 minutes to get started, so you should get a lot of it done in class today, and you won't have very much for homework.